We're discussing the central limit theorem. The central limit theorem states that as you increase the size of your samples, it doesn't matter what the shape of the parent population is. The shape of the distribution of sample means will more closely approximate that of the normal distribution. In this demonstration on the left is a very strongly positively skewed theoretical distribution. And on the right are samples of size 1 that have been randomly selected from this population and recorded over here in a histogram. The skewness for this histogram is 2.1. So it's very strongly positively skewed. Let's go ahead and increase our sample size and see the impact that it has on the skewness. The prediction, as part of the central limit theorem, is that the skewness will decrease as we increase our sample size. For samples of size 5, over here on the right is our distribution of sample means. It's still positively skewed, but the amount of skewness has dropped considerably from the prior skewness of 2.1. Now it's around 1.0 or 1.1. We'll go ahead then and increase our sample size this time to 30. Again, how much will that decrease the skewness of our sample means? Here we go. At this point, we've drawn more than 500 samples, and the skewness for our distribution of sample means is around 0.39. So again, it's getting lesser, but perhaps not as diminished as you might think. We'll go ahead and do this one more time with the sample size of 200. Once more, we have above 500 samples here, each sample consisting of 200 individual values, their average being calculated and recorded here. And this distribution of sample means is much more in the shape of a normal distribution. The skewness is now around 0.1 that's been observed. So as we're increasing our sample size, the shape of the distribution of sample means is becoming much more like that of a normal distribution. I'm going to go ahead and zoom out. And another characteristic you can see is that when we have sample sizes of 200, the sample means are ever so much more close to the true population mean. And so we get very little variability.